5.1 is going to be over polynomials. So let's first talk about what a polynomial is. A polynomial is a function of the form a sub n x to the n plus a sub n minus 1 x to the n minus 1 and go all the way down to a sub 1 x plus a sub naught. Okay, where n is a non-negative integer. Okay, that's really important. We've already been dealing with things like this. For instance, like if we look at like a really simple linear, that is a polynomial by this definition. You see that basically all the a's, those are just numbers. That's the coefficients. It's the x's, the exponent on x is really important. That needs to be a non-negative integer. An integer being a whole number, a non-negative whole number, and it can be 0 as well. Okay, we use the highest one to determine degree. The degree of a polynomial, and I'm going to write poly from now on just because it's shorter. The degree of a polynomial is determined by the largest exponent on x. So we look at all the terms and look and see which x has the largest exponent, and that's going to determine the degree. Okay, for instance, let's say I have f of x equals 2 minus 3x to the fourth. Is that a polynomial, and what's its degree? It is not in standard form, so if we rewrite it in standard form with the highest and descending, you can see that it is a polynomial and it's degree 4. You could say, or you could say 4th degree. Same thing. Okay, another example is the square root of x, a polynomial. Well, we can rewrite that as x to the 1/2 power, and we said a polynomial has to have non-negative integer exponents. 1/2 is not an integer, so this guy is not a polynomial. Let's look at another example. What about this guy? Just h of x equal 8. Well, if I put that there, x to the 0 power, that's the same thing. That shows me that it is a polynomial of degree 0. Last example. Is this a polynomial? And what's its degree? Well, right now, it doesn't really look like standard form of a polynomial, but can we rewrite it to be standard form of a polynomial? We can. Go ahead and multiply this guy out. Okay, that is a polynomial, following the definition up there. Highest term's 5th, and then it goes down to 4th and down to 3rd. So the degree of this is 5th degree. Okay, now let's talk about some important things about polynomials. Okay, if I have some polynomial and it runs across here and looks like this, everywhere it crosses the x-axis is an x-intercept. At x-intercepts, y equals 0, or the function equals 0. Those x values, say we call this a, and we'll call this one b, whatever. They're just going to be numbers. Those values, those x values, is going to make the function equal 0. These are called zeros. That's what they are called, zeros. They are x values that make the function equal 0. Okay? So, a few little important notes here. If f of x is a function, and r is a real number where f of r equals 0, then r is called a real 0 of f of x. So we can make 4 inferences here. R is a real 0 of the polynomial f of x. R, if it is a 0, is an x-intercept. And that means that R is a solution to f of x equal to 0. And so, relating that to, like, say, a factor, like when we factor something, if this is a solution, then x minus r is a factor. Okay, for instance, let's say I have a real simple one here. If I factor this guy, this is finding where the function equals 0. If I factor this guy, I get those two as factors. But then if I set each of those factors equal to 0, I get the x values of 3 and 4. You see how this is related to this? That comes from number 4. If you have an x value, then x minus that value gives you the factor. Okay, so using that rule, let's find f of x given it has zeros at -3, 2, and 5, and put in standard form. Okay, so if x minus 3 is a 0, x plus 3 is a factor. If 2 is a 0, x minus 2 is a factor. If 5 is a 0, x minus 5 is a factor. Now this is not in standard form. To put it in standard form, we need to multiply all that out. Let me factor these two together first. This is going to give me x squared minus 7x plus 10. And then we need to factor this one. It's going to be x to the third minus 7x squared plus 10x plus 3x squared. 7 looks funky. Minus 21x plus 30. Combining like terms, we get negative, or x to the third minus 4x squared minus 11x plus 30. Okay? Now, when we're talking about these factors, there's an important concept we need to bring to the forefront called multiplicity. Multiplicity says that basically says that a factor can be a factor of the polynomial more than once. Okay? For example, if I have this, it can be factored into x minus 3 squared. So we have the same factor in there twice. That gives me multiplicity. So we would say that this has a multiplicity of 2. Now this is important when it comes to graphing, and we're going to see more of that here in a second. So let's look at this example. Let's say I have h of x is equal to 5 times x minus 2, x plus 3 squared, and then 2x minus 1 to the 4th. What are the zeros? What are the zeros and what are their multiplicities? Well, again, to find the zeros is where the whole thing is set equal to 0. Okay, then if we have that, all we got to do is set each of the factors equal to 0 and solve each of those. So we get 2, negative 3, and 1/2. Now it's important to note that this guy, whoops, what are we doing here? This guy has a multiplicity of 2, and that comes from here. And this guy has a multiplicity of 4, and that comes from here. Okay, now let's move towards graphing. How do we graph these things? Okay, so multiplicity is important. Whoops. If something has an even multiplicity, it only touches the x-axis. For example, let's say we're here and this has a multiplicity of, say, 4. The graph's going to come along and just touch it. Okay, so it is an x-intercept because it intersects the x-axis, but it's not, it doesn't cross over it. If something has odd multiplicity, it crosses the x-axis. So it'll look like that. Okay. So let's talk about everything we've talked about. Zeros is where the graph crosses the x-axis. Okay? If the polynomial is degree n, we have at most n zeros. Okay, so however many solutions it has, it can have as up to as many as the degree is. Okay, we talked about multiplicity. Let's talk about turning points. That's actually where the graph changes direction. Now, important note here. A polynomial of degree n has at most n minus 1 turning points. So like for instance, if you know like x squared looks like this, x to the third looks like this. So this is 1 turning point. This is 2 turning points. X to the 4 looks like this. 3 turns. Okay? The last thing we need to talk about is end behavior. Basically, what are the ends going to do? Now, there can be a lot of things that happen in between the ends, but the ends are either going to both go up, both go down, or go opposite directions. So there's 4 different possibilities. First off, we have odd degree and even degree. So that splits it into 2 categories. And then really, all we need to look at, let me back up just a little bit. What we really need to look at is the degree, or the function in its standard form. We got all that other stuff. But basically, we just look at the first term. That's the only one we got to look at. From that, we can determine the degree. We have odd degree and even degree. Okay, it's freaking out on me, but we just got to finish out what we're doing. Okay, if that guy is positive, sorry, it looks like this. If that guy is negative, it looks like this. On the even side, they're both going the same direction. If that guy is positive, they both go up. If that guy is negative, they both go down. Okay, so let's do an example. Let's graph f of x equal to 2x plus 1 times x minus 3 squared. Okay, so let's first find the zeros. That's where f of x equals 0. So we have 2x plus 1 times x minus 3 squared equal to 0. 2x plus 1 equals 0, x minus 3 equal to 0. So we have 2 zeros. This guy, it's important to make note, has multiplicity of 2. That's an even multiplicity, so it's going to touch at just that guy. Okay? Now, let's figure out degree. To figure out degree, we need to do standard form. So let's go ahead and multiply this guy out. So this is going to be x squared minus 6x plus 9, 2x to the third minus 12x squared plus 18x plus x squared minus 6x plus 9 gives you 2x to the third minus 11x squared plus 12x plus 9. Okay, so from that, we can see it's degree 3, so it's going to have 2 turning points. And given our little table for end behavior, if we look at this guy, it's odd degree, positive lead coefficient, so the end behavior, looking back at our table, looks like this. So let's graph it. We're at negative 1/2 and 3. Our end behavior looks like this. It touches here. And we have 2 turning points. So you see that we cross, there's 1 turning point, touch, another turning point, and carry back into our end behavior, and it looks something kind of like that. So that's a real rough sketch and introduction of a graph and an introduction to polynomials. So we'll stop there.